Hello friend, welcome back to our course. Let's continue the linear algebra class, eigenvalue and eigenvector. Before that, I will request you, please subscribe our channel and press a bell icon so that you will be updated with our updated content and video. Okay, so last class we have seen two example 0, 1, 1, 0, 3, 1, 1, 3. So what are these eigenvalue and eigenvector? So I will start with that example only. One example was 0, 1, 1, 0. Second example was 3, 1, 1, 3. Here lambda 1 was equal to 1 and x1 was 1, 1. Lambda 2 equal to minus 1. x2 was 1 minus 1. But in this case lambda 1 equal to 4. x1 was same as previous one, 1, 1. And when lambda 2 is equal to 2, x2 was 1 minus 1. 1 minus 1, right? Okay. So what you are identifying any properties or not? So from there we can identify the properties, right? What properties we can identify? So if we are writing this 3, 0 plus 3, 1, 1 and 0 plus 3, right? And you know this diagonally we have added. So you can take diagonally out like addition 0, 1, 0 plus 3, 1, 0, 0, 1, right? So this will be your, say this vector is A, so it will be your A plus alpha I, right? So alpha is your 3, correct? So one important properties you know that this, if you will find this eigenvalue of this matrix, then you find lambda plus alpha. So you can write determinants of, so you can write actually A plus lambda I x equal to lambda plus alpha. So you will have these properties and anywhere you can use it. So coming next, let us see one property. It looks obvious, but it is not true. What? Say you have a matrix A, you have a vector x, which is lambda x, right? And you have a matrix B, vector x is equal to lambda. So can we write like this? A plus B x is equal to lambda A plus lambda B x. Similar to like this, whatever we have written here, it's look like, can we write like this? No, it's look obvious that one matrix summation, if we will sum the one matrix to the other matrix, then it should be like eigenvalue will be also with the summation of that. No, why? You can see that this is what, this is eigenvector. So this is what, this is eigenvector, this is eigenvector. This is eigenvector for what? A, right? This eigenvector for what? Matrix A. But here this one is eigenvector for B, right? This one is also eigenvector for B. This one is not eigenvector for A. This one is correct, incorrect, right? So this x common you cannot take, right? More specific, if you will write, then we can write like this: A plus be x. This x will be of what? Of matrix A or matrix B, you can say, is not equal to lambda A plus lambda B of A, or A plus B xb is not equal to lambda A plus lambda B of xb, right? So this is important relation. Please don't confuse and don't go in the wrong way. So this is the correct, and so this concept is correct, and this is never be going to be a equal, right? Okay, coming next, we will see one more example like orthogonal matrix. So suppose that this matrix is orthogonal 0 1 minus 1 0. Why this is orthogonal? If we will draw this 0 1, so 0 1 will be like this, and minus 1 0 minus 1 0 will be like, so there will be a 90-degree. So that's why this matrix is called orthogonal matrix. So now we have to find this eigenvalue and eigenvector. Let us see directly. Directly we can find without lambda or not, right? So you have to find this eigenvalue and eigenvector. Lambda equal to what and x is equal to what. So how we will find? So we know by seeing that we know lambda 1 plus lambda 2 equal to trace of matrix A. Like, so lambda 1 plus lambda 2 equal to 0, and we know lambda 1 lambda 2 is equal to determinants of A, and determinants of A is 1, right? So you have two equations. One is saying that lambda 1 plus lambda 2 equal to 0, and second equation it is saying that the multiplication of lambda 1 and lambda 2 should be 1, right? So how it's possible? It is not possible, and we cannot find by this method. So let us see, go step by step by whatever we have studied to find the lambda of this matrix. So we have to do 0 minus lambda, 1 minus 1, lambda, 0 minus lambda, and once you will multiply it, you will find lambda square plus of 1 equal to 0, and lambda is equal to plus minus I, right? Where I is the imaginary number. Where I is imaginary number. Okay. So now this satisfying, this equation is satisfying. Yes, I plus I minus I will be 0, and the multiplication of I and minus I will be 1, right? So this is the case of imaginary eigenvalue. So one important relation you can find it here, like orthogonal matrix. Orthogonal matrix will have always the imaginary eigenvalue, right? So let us move forward, and we will see some example of triangular matrix. So let us say take any triangular matrix 3 1 0 3. Let us take, and you have to find this eigenvalue and eigenvector. Let us find by ordinary method whatever we have, minus lambda and 1 0 3 minus lambda. So you will have 3 minus lambda square equal to 0, and lambda 3 minus lambda equal to 0, and lambda equal to 3. Okay, so why we have taken this example? Why we have taken this triangular example? Because you see, lambda is only one value it is giving to the matrix. It is 2D matrix, right? And as per the 2D matrix, eigenvalue and eigenvector should be in the twice, but here lambda is equal to, you are getting 3. So what will be this eigenvector? So here it will be 3 minus 3, it will be 1 0 3 minus 3, x1 x2 should be equal to 0 0, right? So it will be 0 1 0 0, x1 x2 x2. So here equation will become, it will be 0 plus x2 equal to 0, and the third one is 0 plus 0 equal to 0. Oh, so x1 will be any number and x2 will be 0. So from this equation you are finding x2 equal to 0 and x1 will be, suppose 1, any number means 1. So your value, so your x will become, so your lambda is 3 and x is, sorry, here only x single eigenvector is there, and you can say 1 and 0, right? So one more conclusion you got from this triangular matrix, that your eigenvalue and eigenvector may be less than the size of the matrix, right? Okay, so now the time is for question and answer. So I will give you a question. So if you are not able to solve it, please ask in the comment box. If you are able to solve it, means it's good and you are knowing all these eigenvalue and eigenvector concept. Okay, so here your question, please solve it and please answer us. If a vector a, sorry, if a matrix A is equal to 1 2 3 0 1 minus 2 0 1 4, then question A, find lambda, that is eigenvalue, for A square. Question B, find lambda for A inverse minus I. Find the rank of matrix. Okay, so here is your question. You solve it. With this question, I would like to end today's class, and we will request you, if you have not subscribed our channel, please subscribe it and press a bell icon so that you will be updated with our updated content. I will also request you, please go through our website. Question is there, so go it and solve it. तब तक के लिए बाय बाय. Thank you.